Hardware acceleration, scaling Ethereum like Solana's blockchain. Introduction. Blockchain technology has revolutionized the way we think about data, security, and decentralization. However, as blockchain networks like Ethereum grow, they face a fundamental challenge: scaling. Blockchain networks must balance three crucial elements: scalability, security, and decentralization. Known as the blockchain trilemma, this delicate balance has made it difficult to develop scalable solutions without compromising the integrity of the network. In our exploration of blockchain scaling, we came to a breakthrough insight by drawing an analogy to photography. This analogy helped us understand how blockchain networks, like Ethereum, could overcome their scaling challenges by recognizing the role of hardware acceleration, an approach already successfully implemented by Solana. Through this lens, we will delve into how block size, scalability, and security, the key components of the blockchain trilemma, can be optimized, much like adjusting the settings of a camera to achieve the perfect exposure. The photography trilemma, a perfect analogy. Shutter speed will scalability. In photography, shutter speed determines how long the camera's sensor is exposed to light. A fast shutter speed captures quick moments but might underexpose an image, while a slow shutter speed lets in more light but risks motion blur. Similarly, scalability in blockchain refers to how quickly the network can process transactions. Just as an ideal shutter speed allows for the best exposure without motion blur, the scalability of a blockchain must be optimized to handle more transactions per second without compromising network performance. For blockchain networks, scalability issues arise when transaction speeds are slow or the network becomes congested under high demand. To scale a blockchain effectively, its design must allow for faster processing times while maintaining network integrity, just as a photographer must adjust shutter speed to get the perfect image. ISO equals security. In photography, ISO determines how sensitive the camera's sensor is to light. A higher ISO allows for better performance in low-light conditions, but can introduce grain or noise, diminishing the image's clarity. For blockchains, security is akin to ISO. It ensures that transactions are protected and data is stored safely, preventing malicious attacks or tampering. Just as a photographer adjusts ISO to balance light sensitivity and image quality, blockchain security must balance the need for protection with the cost of additional processing power. Too much security can slow down the system, just as a very high ISO can create a noisy image. A well-balanced approach to security ensures that the blockchain remains resistant to attacks without compromising performance. Aperture, block size. In photography, the aperture refers to the size of the opening in the lens through which light enters. A larger aperture lets in more light but reduces the depth of field, making the area in focus smaller. A smaller aperture allows for more of the scene to be in focus, but lets in less light. Similarly, block size in blockchain networks determines how much data can be processed in each block. A larger block size allows more transactions to be included, but it can compromise decentralization by requiring more powerful hardware to validate blocks, making it harder for individuals with less powerful machines to participate in the network. Just as photographers must balance aperture to maintain clarity and focus in an image, blockchain developers must carefully manage block size to ensure decentralization and inclusivity without sacrificing scalability. The role of external lighting, hardware acceleration. The final key element in photography is external lighting. Whether it's natural light or artificial lighting like flash bulbs, a strong external light source can overcome the limitations of aperture, shutter speed, and ISO. By adding more light to a scene, photographers can achieve a well-exposed image without the need to compromise on other settings. Similarly, in blockchain, hardware acceleration acts as the external lighting that enhances scalability without sacrificing security or decentralization. By integrating custom hardware and specialized infrastructure, blockchains can achieve faster transaction processing speeds and higher throughput. This external solution eliminates the constraints imposed by traditional blockchain designs, enabling the system to scale effectively. This content is brought to you by Bobby Gigs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. 3. The case of Solana, harnessing hardware acceleration. Solana has taken a bold approach to blockchain scalability by incorporating hardware acceleration at its core. Unlike Ethereum, which relies on layer 2 solutions like rollups to scale, Solana's proof of history, POH, consensus mechanism, and purpose built hardware have allowed it to process transactions at lightning speed. With hardware acceleration, Solana achieves high throughput with low latency, enabling fast transaction speeds without compromising decentralization. The use of custom built hardware optimized for Solana's blockchain design reduces bottlenecks and allows the network to handle thousands of transactions per second, TPS, far outpacing Ethereum's current capabilities. The key takeaway from Solana's approach is that hardware acceleration provides a sustainable and scalable solution that doesn't require trade offs between performance and decentralization. By building a blockchain that leverages custom hardware, Solana has set the stage for future scalability as the network continues to grow. Ethereum's scaling struggles, the roll-up approach. Ethereum, on the other hand, has faced significant challenges in scaling. In an attempt to address scalability, Ethereum introduced the roll-up system, where transaction data is processed off-chain and then compressed and posted back to the Ethereum main chain. While innovative, this approach has not fully addressed the underlying scalability issues and has led to fragmentation within the Ethereum ecosystem. The roll-up-centric model still depends on Ethereum's Layer 1 chain, and it doesn't completely eliminate the bottleneck caused by the base layer's inability to handle an increasing number of transactions. Roll-ups, while helping with scalability in the short term, still result in a fragmented system, where different roll-ups operate independently and create inefficiencies in transaction processing. Ethereum's failure to recognize the value of hardware acceleration in addressing these scaling challenges may explain why it continues to struggle with high gas fees and slow transaction times during periods of heavy demand. How Ethereum could learn from Solana, embracing hardware acceleration. If Ethereum were to embrace the hardware acceleration model used by Solana, it could overcome its scaling challenges without relying solely on roll-ups. By integrating custom hardware solutions into its infrastructure, Ethereum could achieve faster transaction speeds, lower costs, and higher scalability without sacrificing decentralization. Ethereum's existing proof-of-stake (POS) consensus mechanism could be enhanced with hardware acceleration to handle more transactions per second without compromising security. Ethereum's network could also develop purpose-built hardware that complements its POS model, enabling it to scale more effectively and compete with newer, more efficient blockchain networks like Solana. Incorporating hardware acceleration would position Ethereum to meet the growing demand for smart contract processing while maintaining the principles of decentralization and security. The success of Solana demonstrates that it's not just about faster transactions. It's about integrating hardware solutions into the blockchain design to provide a holistic approach to scalability. Addressing the blockchain trilemma with hardware acceleration. By incorporating hardware acceleration, both scalability, security, and decentralization can be optimized. Hardware acceleration allows blockchains to scale effectively by processing more transactions without compromising security or centralizing the network. Custom hardware can offload some of the computational tasks, reducing the strain on individual nodes and enabling the network to function more efficiently. The key to achieving this is finding the right balance, just as photographers carefully adjust their settings to get the perfect exposure. By incorporating powerful hardware solutions, blockchain networks like Ethereum can scale without sacrificing the foundational attributes of the system. Conclusion. In conclusion, the analogy between photography and blockchain scaling offers a fresh perspective on how to solve the blockchain trilemma. Just as external lighting in photography can eliminate constraints and allow for optimal exposure, hardware acceleration in blockchain networks can enable scalability without compromising decentralization or security. Solana's success provides a clear model for how custom-built hardware can drive blockchain scaling, and Ethereum could benefit from adopting this approach to overcome its current limitations. By embracing hardware acceleration, blockchain networks can scale effectively, enabling broader adoption and unlocking new potential for the future.